I think this is where we left off last time. So I'm going to start right here and solve this right triangle. And remember, when we say we want to solve a right triangle, what we mean is we want to find all angle measures and all the leg lengths. So what do we have here? We know, first thing we can do is we can figure out the measure of angle P, right? Because we've got a right angle, which is 90. We've got this top angle Q here, which is 53. So that gives me 143. So of course the measure of angle P is 180 minus 143. So it's going to be 37 degrees. Okay, now I just have to find out the lengths of side P and side Q. So why don't we just start by looking, I'm going to reference Q first. So I'm going to use the angle opposite, I'm sorry, if I'm looking at side Q, the angle, okay, let me start again. If I start by looking at this angle here, 53 degrees, what do I know? I know that the sine of 53 equals the side opposite over the hypotenuse, right? Well, the side opposite is Q. That's what I was trying to get at a second ago. And the hypotenuse is 30. So I can use this ratio here to solve for Q. What do? I just multiply both sides by 30. So I know that Q is going to be 30 sine 53. And when I punch that into my calculator, I'm going to get Q is 23, and actually it's approximately, so I should probably use that symbol, approximately 23.96. Okay, now the only thing left for me to do is to find the length of side P. Could I use this 23.96 and the 30, which is the hypotenuse, and the Pythagorean theorem? Of course I could, but I think that's going to be a lot more tedious than if I just use another trig function. And besides, I've rounded off side Q, so I'm going to have a slight error in there. So I'm going to just use another trig ratio. I'm going to use the angle 53 again. And what is P with relation to 53? Well, it's the side adjacent. So I'm going to use the cosine this time. The cosine of 53 degrees equals the side adjacent, which is P, divided by 30. And so once again, I just have to multiply both sides by 30. So P is going to be 30 times the cosine of 53 degrees. And that's going to be approximately 18.05. And let's see, we don't have units on there. So my question to you is, could I have used 37 degrees instead of 53 degrees? Of course I could. If I had used 37 degrees though, if I had said the sine of 37 degrees, what is the sine of 37? Well, it's the side opposite, so that would be P divided by the the hypotenuse, side opposite over hypotenuse. So if I wanted to use 37, I would get the same answers, but it would just be this way. So 30 sine 37 equals P. So you can type that in there and make sure that it is approximately 1805. Let's just do it. 30 sine 37. Let me get out of there. 30 sine of 37. And I get 18.05, and that is what I got just above when I used the angle 53 degrees. So I could use either angle that I want. I just have to make sure I have my trig ratios correct. All right. We have another right triangle to solve, so I think what you should do here is pause. I'll work it out for you, and then actually, what do we have left? We have 3 problems left. So why don't you try to do these 3 problems, and then I'll have the solutions for you and you come back and check. I'll quickly talk you through these. So I want to solve this right triangle here. I guess I should start with the side. I could start with side A, and all I have to do is use the Pythagorean theorem, right? A squared plus 80 squared is going to be the hypotenuse squared. And when I do that math, I get that the side length of A is 39. So hey, 39, 80, 89, that would be a Pythagorean triple, would it not? All three integers? Yes, indeed. So maybe add that one to your list. Probably won't see that very often, though. All right, and if I want to find, I guess it looks like I started with angle B. What do I have? I have the side opposite B and the hypotenuse. So if I write that trig ratio, I know it's the sine. The sine of angle B is 80 over 89. And then, of course, I have to use my inverse sine function of 80 89ths. And when I round that angle off to the nearest hundredth, I get 64.01 degrees. Then when I want to find angle A, I could say 90 plus 64.01, add those and then subtract from 180. If I did that, I would get 25.99, but I went ahead and used the trig ratio anyway. And so if I'm looking for the measure of angle A here, then I have the side adjacent to the angle A and the hypotenuse. So I use the cosine, punch that into my calculator, and I get 25.99. And of course I know these two have to add up to 90 degrees, right? Because the other two angles in a right triangle have to be 90. So sure enough, they do. So I feel confident in that answer. And then we have this problem, which says use the figure at the right to determine what the measure of angle Y is. So really my only choice here, well, I do have another choice. I could use the Pythagorean theorem to find out what the length of the hypotenuse is, but I don't want to because that's more work than I need to do. So I'm just going to use my trig ratio. And the only one I got here is tangent because I got the side opposite and the side adjacent. So I know that the tangent of y is 100 over 41. And then I'm going to need to do the inverse tangent of 100 over 41. And that it approximates to 67.71 degrees. And then they ask us this question, suppose you know the lengths of all three sides, would it matter which trig ratio you use? What do you think? Of course it wouldn't matter, right? As long as I use the correct one, I'm going to get the same measures. If you don't believe it, and you want to prove it to yourself, then use the Pythagorean theorem to get the measure of this hypotenuse and try it with the other. Try it with sine and cosine and see if you come out and get the same measures of the angles. Go ahead and try it. Good exercise. Okay, and down here we need to find the values of W and X. Oops, and it says round to the nearest tenth. So I need to back off one there. Got to follow my instructions. Okay, so quickly I wrote up here W equals 3. How do I know that W equals 3? Well, hopefully you realize this too. Oh, that's a 30, 60, 90 triangle. This one right here, it's a special right triangle. So that means W is the short side because it's across from the 30-degree angle. And I know that the short side is half as long as the hypotenuse. So that's how I got W equals 3. And now that I have those two sides of this triangle, the one on the right, I'll color it green. And what sides do I have with respect to angle X? Well, I've got the side adjacent and the hypotenuse, so that tells me I'm going to use cosine X. And be careful, be very careful here, guys. Don't go thinking that this green triangle is a 3, 4, 5, because look, your hypotenuse is 4, and it would have to be 5 if this was a Pythagorean triple. So that is not a Pythagorean triple. In any event, when I do my inverse cosine of 3 over 4, I get 41. It's approximately 41.4 degrees. All right, write yourself a summary, maybe your essential question. If you did not do that, let me know next time if you have any questions about this. And our next lesson will be on angles of elevation and depression. So we'll be using a lot more sine and cosine and tangent and their inverses. So make sure you get plenty of practice.